Welcome back. We are now moving to chapter 3, where we're going to be discussing bonding. A bonding is when you have two atoms, two elements that come together through a chemical bond. The reason why they're going to come together is to become more stable. Now, how do they come together? In order to come together, one of the electrons is going to gain and the other one is going to lose. That's the case if you have a metal and a non-metal. So if you have a metal, the metal is going to lose. And the non-metal is going to gain. If you have two non-metal atoms, they're going to share electrons. Electrons will gain, lose, or share electrons in order to reach that stability, that electron configuration of a noble gas. Noble gases are very stable. So a lot of the atoms, they want to create a bond with another atom in order to have the electron configuration of a noble gas because they are very stable. Usually the noble gas that is nearest. So for example, hydrogen, which is number 1, would like to exist as a H2 in order to have the same electron configuration of helium. Helium is a noble gas and it's a very stable gas. We have two types of bonding. We have ionic, which is when you have a metal and a non-metal, metal and a non-metal. That's when you're going to have ionic bonding. In the metal, it's going to give the electron to the non-metal. It's always going to go from the metal, the electron is always going to travel from the metal to the non-metal. Covalent bond is going to exist when you have two non-metals, two or more non-metals. And what's going to happen is that in here, your electrons are being shared. And the bond that creates, so for example, Cl and Cl, that bond is a covalent bond. This is a covalent bond. Covalent bond. And those electrons are being shared. They're not being transferred. Just a stable configuration fact, noble gases such as helium, neon, argon are inert gases. The word inert means that they don't like to react with anybody else. They are happy the way they are. A theory, the inertness of a noble gas results from their electron structure, with the exception of helium. The reason for that is all atoms, all inert gases, with the exception of helium, all those gases have 8 electrons on their outer shell. They have 8 electrons. Oh, maybe I should do it with a different color. They have 8, 1, 2, 3, 4, 5, 6, 7, 8. They have 8 electrons on their outer shell and it's considered them to be happy. Deduction, other elements that can alter their electron structure to become like those noble gases will become less reactive in doing so. Pretty much if an atom can figure out a way to have 8 electrons on the outer shell, they will be less reactive, and that's what everybody wants. They want to be less reactive. So ionic bonds are going to form between a metal. Remember, a metal is going to be on the left. Metals are on the left of the periodic table, and a non-metal. So we have an example here with sodium, which is a metal, and it likes to give 1 electron. That electron is going to go to chlorine. The likes to accept 1 electron. As a result, between both of them, Na, which is a metal, Cl, which is a non-metal, they're going to create an ionic bond. That is an ionic bond between them. The sodium is giving the electron to the non-metal, which is the chlorine. Covalent bonds are going to exist when you have two nonmetals. We have roughly 19 nonmetals on the right of the periodic table. They combine sometimes also with a metalloid. When they combine, they form a molecule. A molecule is a compound or element containing two or more atoms joined together through a covalent bond. For example, a molecule would be water. Why would a molecule be water? Because hydrogen is a nonmetal and oxygen is a nonmetal. Because they are both nonmetals, that means that this bond is a covalent bond. They're joined through a covalent bond. And we're gonna go into more detail later on. Notice here you have a hydrogen and a hydrogen. What they're doing is they're both sharing their electrons. A bond, this line is a bond, is going to result with sharing 2 electrons. So each bond represents 2 electrons. If I have a double bond, such as this, I'm representing 4 electrons. If I have a triple bond, I'm representing 6 electrons. The word ions means that you carry a charge, That charge can be positive or negative. So ions means that you have a species that carries a charge. What that means is that that atom doesn't have the same number of electrons and it does not have the same number of protons. So if you look at, let's see, what do we want to look at? Let's look at, if we look at lithium versus lithium plus. This lithium has 3 protons and 3 electrons. The second lithium with a charge has 3 protons and 2 electrons. So whenever in a species an atom has a charge, it means that it doesn't have the same number of protons and electrons. Ionic compounds, which are composed with a metal and a non-metal, they are attracted by opposite charge. So that attraction of going from positive to negative, opposites attract. So that attraction is what makes the bond, the ionic bonds. There are 2 types of ions. You have cations and you have anions. Cations are plus charges, anions are negative charges. Cations are the ones giving the electrons. Anions are the one accepting electrons. Cations are positive charge. A cations have fewer electrons, meaning it gives away electrons. So for example, we have here sodium, which is Na without a charge. This is the electron configuration. But if we look at sodium with a charge, this electron is coming off. So this is the electron configuration of sodium plus. So it gives, like it has fewer electrons. Cations gives off electrons. On the other hand, anions are going to accept electrons. Here's another example of a cation. So cation, Mg, is not a cation. It's just a atom stable. This one, it's going to give 2 electrons and it's going to become Mg2+. Notice that the electron configuration, this gets deleted because now it has less. Instead of having 12 electrons here, 12 electrons, Now this one has 10 electrons, and it's called a magnesium ion. This without a charge is called a magnesium atom. Magnesium ion means it has a charge. It's carrying a charge. Anions are negative charge. They like to accept electrons. What that means is that an anion is going to have more electrons than protons. We have an example here. Chlorine. Chlorine has 7 electrons on the outermost shell. In total, it has 17 electrons, right? This is the outermost shell. This is the outermost shell. But in total, it has 17 electrons, and it has 17 protons. And that is considered a chlorine atom. However, when it becomes an anion, it's going to gain 2 electrons. So instead, it's going to have 10, 16, 18 electrons. It's going to have 18 electrons because it accepted 1 electron, and it becomes a chlorine ion. The word ion, it just means that you're adding a electron. Metals like sodium and magnesium for cations. All metals are going to like to give electrons. So they become cations. They lose electrons. So either you lose 1 electron, such as sodium, you lose 2 electrons, such as magnesium, or you lose 3 electrons, such as aluminum. They are going to become cations, and the reason why they like to get rid of electrons is so that outermost shell now is full with 8 electrons. Non-metals such as chlorine, oxygen, they like to form anions. For example, chlorine likes to accept 1 electron, so its outermost shell now has 8 electrons. Oxygen likes to accept 2 electrons, so the outermost shell now has 8 electrons, then so on. The octet rule is basically this rule where an atom is gonna have 8 electrons on the outermost shell, the shell with the most energy. Those electrons are going to be called valence electrons. The reason why those electrons are important is because those are the electrons that are going to participate in the reaction. Those are the electrons that are going to form those bonds, whether it's ionic or covalent bond. Relating group number to ionic charge for a main group. Elements in the same group, such as lithium, sodium, they are going to have the same charge. Every element in group 1, with the exception of hydrogen, will become a cation and will become a cation with a plus, only 1 electron. So every atom in group 1, with the exception of hydrogen, likes to give away 1 electron. When it gives the electron away, it's going to become a cation with a positive charge. Every atom in group 2 is going to become a cation by giving off 2 electrons. On the other hand, groups such as 7A, your fluorine, your chlorine, are going to gain 1 electron. So everybody in that group is going to have a -1 charge. Everybody in group 6A is going to have a -2 charge. Notice here how we have that this group 1 has 1 valence electron. They like to get rid of 1 electron. Group 2A likes to get rid of 2 electrons. Group 3A, be careful, 3A is where aluminum is. So here's your 3A groups. They like to get 3 electrons. They're going to become aluminum 3 plus. This will be beryllium 2 plus. lithium plus. On the other hand, we have the anions, they like to receive electrons. So for example, oxygen, any atom in group 6A, like oxygen, sulfur, selenium, they are going to gain 2 electrons. Sorry, they're going to gain 2 electrons. So it's going to be oxygen, -2. They become anions. We have 7A, such as fluorine, chlorine, bromine, and iodine. They are going to gain 1 electron, having a negative charge. Here are the charges that you need to memorize. These are the charges that these atoms will always like to form. This is something that you need to memorize. There are some atoms on the transition metals that they like to carry more than 1 charge. And when we are naming these compounds, you have to tell me which charge is that particular metal carrying. This one you don't have to memorize, you're just gonna have to understand how to figure it out which charge they are carrying. So these are your type 2. This whole thing is your type 2 metals. And this group 1 and 2 and aluminum are your type 1 metals. And this is gonna make sense later on, type 1 metals. Ionic compounds is formed when a metal, notice that the metal is the one doing the transferring to the non-metal. The non-metal is accepting. The overall charge of those two is going to be 0. So for example, NaCl, the overall charge equals 0. So Na carries a plus charge, Cl carries a negative charge. Positive 1 plus -1 equals 0. Notice here we have calcium and fluorine. What that means is that calcium has 2 electrons to give away, so you're gonna need 2 fluorines. So it forms calcium fluoride. So this equals 0. What that means is that you have +2 plus, and then you have 2 fluorines, and fluorines carries a -1 charge, and that's gonna equal 0. It always have to equal 0. Same thing with here. Notice that if you have aluminum oxide, that means that aluminum, so I'm gonna show you how to find out that, so in this case, aluminum is gonna be 3, because you have 3 aluminum, no, sorry, you have 2 aluminums. You have 2 aluminums, and the charge of aluminum is 3, because it's always gonna be +3. Aluminum is not gonna change. Plus, you have 3 oxygens, and the charge is always gonna be -2. That is going to equal 0. How to write formulas. So we always going to write the metal first. When we are writing formulas, the metal is gonna come first and it's going to follow by the non-metal. So we notice how we always put the metal first and then followed by that non-metal. What we're going to do is we are going to what's called crisscross. So in this case, there's a +1. In this case, there's a -1. So this number, not the charge, is gonna become the subscript of chlorine. And this number, just the number, the magnitude, is going to become the subscript of potassium. So it becomes potassium 1 CO1, but because it's just 1, we just write KCl. Notice here, calcium carries a charge of 2 plus, so we put the 2, is gonna be the subscript of oxygen. Oxygen carries a charge of -2, it's gonna become the subscript of calcium. So we write Ca2O2, but we always want to represent the equation at the lowest ratio possible. So we divide both by 2, and the answer will be CaO. And it's given here. Notice how the overall charge is 0. We always want to represent it in the lowest possible ratio that we can. Notice here we have calcium that has a charge of 2, and chlorine has a charge of 1, -1, right? We don't care about the sign for this. What we do is we're gonna crisscross. The 2 is gonna become the subscript of chlorine, and the 1 is gonna become the subscript of calcium. So calcium 1, chlorine 2, but we don't put the 1, so it becomes calcium chloride. Okay, now let's see if you guys can practice it on your own. So try to create the chemical formula when you have barium and chlorine. Notice that the charge is being given to you already. So this is barium, has the charge of 2 plus, chlorine -1. So when you try them, you want to crisscross just the number, and your answer should be BaCl2. Try to select the correct formula for each ionic compound. Remember, try to review what's an ionic compound: metal and non-metal. Take a minute to try to answer that by yourself. Here's your answer. Okay, so here I have it in another way, just same thing, just representing it a different way. Notice here we have aluminum, which carries a 3 plus, and we have oxygen. When you crisscross, that 2 from oxygen becomes the subscript of aluminum. The 3 of aluminum becomes the subscript of oxygen. Same here, we have magnesium with 2 and oxygen with 2. When you crisscross, they become the subscripts. The way we write it will be MgO, because we want to represent it in the lowest ratio as possible. Okay, now we're going to go into naming ionic compounds. We're going to start by naming ionic compounds. Sorry. Oops, what happened here? Here we go. We're going to start by naming ionic compound. We have your type 1 and we have your type 2. Your type 1 is going to be those compounds that have a metal, and that metal is from group 1, 1A, group 2A, and group 3A. They're going to be your type 1. Your type 2 are going to be your transition metals. And these metals, they're going to change their charge. They're going to vary their charge. Now, how do you name type 1 ionic compounds? Type 1, they're always going to have the same charge. Their charge is not going to change. So therefore, these are the ones. So you want to memorize them. This is your type 1. Blue equals type 1 metals. and you want to remember this charge. So because their charge is never going to change, we don't have to like representing on the name because everybody already is going to know what charge they have. So when we have, we call those binary compounds, that they are when two elements come together, one being a metal and one being a non-metal. The way we're going to name it is you just name the cation, which is the metal. So for example, if I have sodium, and if I put it with chlorine, you're just going to say the word chloride. You just end it, take the base name and the end, change the ending, chloride. And that's how you would name it. Notice here, I give you an examples on how the naming would change. Fluorine, change to fluoride. Iodine, change to iodide. Nitrogen, change to nitride. So here we have an example. If I have potassium, that's the metal, then you will say potassium chloride. Calcium oxide. Notice that I don't have to tell you the charge because you already know that calcium is 2 plus and oxygen is 2 minus. You already know that because these charges are not going to change. The charges are always going to stay the same. So let's have a practice. How will you name this one? What type of metal is it? Type 1 or type 2? Type 1. So it will be magnesium fluoride. How will be the formula of this one? Potassium bromide, calcium oxide, strontium bromide. Strontium is 2 plus, bromine is -1, and your crisscross is SR, BR2. For practice, give the names of the following. First, identify your cation and identify your anion. Figure it out whether you have a metal type 1 or type 2 for all of them. So notice this is type 1 metal, type 1 metal, type 1 metal. Figure it out their charges. By now you should memorize those charges and do the same with the anions. So then you have a calcium, cation, aluminum, and magnesium. Then you figured out the anion that you have present. You have oxide. Remember, it's not oxygen. You're going to change the ending. Sulfur, sulfide, chlorine, chloride. The last step, you just put it together. Calcium oxide, aluminum sulfide, magnesium chloride. Let's try this on your own. How will you write the formula? So pretty much crisscross. Metals are this one, so they come first. So it's going to be Na, Br, Na, 2, S. Try that all the ones by yourself. And here are your answers. Now we're going to name type 2 compound, ionic compound. These type 2 are going to be those that carry your transition metal. Those metals are going to vary in charge. Sometimes they'll carry one charge, and other times they'll carry a different charge. When that's the case, you actually have to tell me, or you don't have to, not telling me, right? But in general, you have to say what charge is that metal carrying in the compound. And the way we're going to do that is by using Roman numbers. For example, here you have iron. However, in this case, this iron is carrying a 2 charge. In this case, this iron is carrying a 3 charge. Copper is carrying a 1 charge. Copper is carrying a 2 charge. So we have to let our audience know which charge is that is carrying when combined with a specific atom. the way we're gonna do it is we still name the metal regular, then you have to put in parentheses the Roman numbers representing the charge, and then you do the non-metal base and change the ending of the non-metal in I. So very similar, the only difference is that we're sticking the charge between the metal and the non-metal. For example, we will say iron 2, iron 3, and then we just name the non-metal ending it in I. Here's the comments. Don't ignore the older name. We're not going to be using the older name. We're going to be using the more convenient, easier way. So chromium can be 2 or can be 3. Iron can be 2 or can be 3. Mercury could be 1 or 2. Lead could be 2 or 4. Determine the charge from the formula. So that's going to be very important. It's also called oxidation number. We have to determine the charge. I'll give you an example. If I give you this Mn O2, Mn is a transition metal. And if I ask you what is the charge of the metal, you can't just see it and determine that it's 2. That is not the case. You have to find the charge. I posted a video on this. The overall charge of this compound is 0. What that means is that the charge of manganese and the charge of oxygen has to equal 0. In this case, how many oxygens do you have? 2. What is the charge of oxygen? -2. Charge of oxygen. Now, plus, how many manganese do you have? 2. What is the charge? We don't know, so let's call it X. So 2 times X is 2X plus 2 times -2 is -4. Oops, equals 0. So we're gonna move the 4 to the other side. We have 2X equals 4. Divide both sides by 2. X is equals 2. So in this case, the name will be manganese in parentheses 2, and then you're going to have oxide. But let me give you an example where that's not going to be the case. For example, I'll bring it up later. So here's an example. Notice that we're trying to figure out the charge of chromium. The whole thing is going to must equal 0. That -1 is the charge of bromine. And then when we set it up, so it's going to have X plus 3 -1 equals 0. X is going to be equal to 3. So the way you name that compound would be chromium 3 bromide. Whereas here, same thing, it would be iron 3 chloride. So you want to make sure that you tell us the charge. And remember that everything, that compound has to equal 0. So that parenthesis is the charge, and in here is the charge of the metal, and in the second parenthesis is the charge of the non-metal. Let's see if you guys can try this one. I'm very, very curious if you guys can figure out the charge of lead on this one. I think I did the other one wrong. Let's see, 0. We have 1 lead, so we're going to have X plus 2 times -2. X is equals 4. So it's lead 4 oxide. I did the other one wrong if I'm not mistaken. Let's see if I did it wrong. I think I did. Let's see this one. Yes, did it wrong. There shouldn't be any 2 here because there's only one. There's only one magnesium. There's also only one manganese, so it's just 1. So X, this is not, X is equals 4. I knew something was wrong. So it's manganese 4, it's not 2. And if you guys didn't catch my mistake, let me know and I can re-explain this. So going back to this, see if you guys can name this. I already told you the name of that one, which is lead 4, not lead 2. Not lead 2. What is the charge of chromium? So it's going to be equal 0. The charge of nitrate, if you don't know yet, is -1. This is a polyatomic, which is coming up. So you have 3 nitrates, and the charge is -1 plus X. So for X, then the charge is 3. So it will be 0. See. Here's another example. How will you name this ionic compound? Type 1 or type 2? Figure it out, the charge of the iron. The charge for the iron turns out to be 2. So the correct name would be iron 2 fluoride. Here's another one for you to try. We actually did it already. It is not manganese 2. It's actually manganese 4. So now we're going to focus on polyatomic ions. And what polyatomic ions are a group of atoms that exist together, and they are going to carry a charge. For example, nitrate, it's NO3 with a -1 charge. So this is a polyatomic ion, and it's considered um, it's named nitrate. Now, the reason why they're considered ionic is because this polyatomic ion will usually be next to a metal. So for example, it can be next to a, let's give you Mg. What's the charge of Mg is 2 plus. And what is the charge of NO3? And we usually put this in parentheses. It's a -1. So if I want to create a formula, it would be Mg parentheses NO3. And the way you will name it is you literally just say the name of the metal and the name of the polyatomic. So magnesium nitrate. Notice here we have potassium, and you want to recognize that the polyatomic nitrate. Iron, because it's transition metal, you want to make sure that you tell us the charge. And HO negative is hydroxide. When you have 2 polyatomic together, such as NH4 plus NO3 minus, you just name both polyatomic. So ammonium refers to that, and nitrate refers to that. Here's a list of polyatomic ions. The following are the ones that you're going to have to memorize. The ones I'm circling. Those you have to memorize. You have to memorize. and you have to memorize those. There is a way of figuring out how to naming, but it's more complicated. So we're just gonna focus on just memorizing those. It's important that you memorize how many oxygens and the charge that that specific um, polyatomic is carrying. Because notice here, so the reason why it's a little bit difficult to figure out how to name them is because they're coming family. For example, this family of nitrogens and oxygens together, one of them has a 2 oxygens, one has a 3. So the one with the 3 oxygens carries, we give it an N8 nitrate. The one with the less amount of oxygen gives it 8 nitrite. Notice here, this is the family. The one with the most gets the ending 8. The one with the least gets the ending 8. So for you to know, you need to figure it out how many are in that family. This family has 4. So the one with the very least gets hypo and 8, followed by 8, then 8, and the one with the most gets the word per in front of it and 8 at the end. So it makes it a little bit difficult to try to figure out how to name it. So instead, just memorize the ones I have given you. So for example, write the formula of aluminum bicarbonate. So first, what is aluminum? Al, and then what is bicarbonate? This. So when you put it together, you want to crisscross, and you get aluminum carbonate. Here's another one, sodium phosphate. So what is sodium? Na, and what is phosphate? PO4 with a charge of 3. So Na plus PO4 with a charge of 3. Crisscross, that will get you your answer. So it's important that you recognize your polyatomic ions. And if you have a metal that is a transition metal, you have to tell us the charge of that metal. Here's the list again of examples on when do we use polyatomic ions. So they're important because they are in a lot of the chemicals we use. Here's another check your understanding. Try to think, try to name it by yourself. Here's the answer. Another question. Here's the answer. You can pause the video to try to see if you can answer the question by yourself. Here's another question. Here's your answer. The last question, practice question. And here's the answer. So this chapter really focuses on naming. I will be posting a lot of practice problems if you guys need it. I'm not posting extra worksheet. Hopefully that will help you name.